Hello everybody, this is Mr. Narron. I wanted to give you guys a little bit of practice with the graphing practice worksheet. You guys should, by the time you're watching this, should have already copied the notes on the difference between a math graph, which is x versus y equals mx plus b, and a science physics graph, which might be position versus time, velocity versus time, acceleration versus time later on. So you should have already copied those notes. You should know how to linearize a graph based on the shape that you get. But the point of this is I'm going to go through a couple on the graphing practice worksheet, and hopefully that'll help you guys out. It'll make you understand it a little bit better. Let's start by reading the instructions, because this is something a lot of students don't do. You guys will be surprised, or probably you wouldn't. So, instructions says first determine what type of graph it is, or it will be, by plotting the data in the first graph. So that's step number one. We're going to plot the data we've been given, so we've got an x and a y. It's not an x and a y. In this case, it's actually voltage, okay, voltage and current, but we're going to plot the x versus y first, and be sure to label your axes correctly. Give it an appropriate title, make sure you have units, and it also says proper axes scaling. So in other words, well, I'll show you more of that in a second. Then you should determine what needs to be done to linearize the data and put the appropriate values in the third column in the table. Then plot the linearized data in the second graph, and then we'll correct the units, we'll correct the labels, blah, blah, blah. Lastly, determine the physical version of the y equals mx plus b equation with the correct units and variables. So in other words, this first graph is probably not going to be y equals mx plus b. It might be current equals the slope times voltage plus whatever our intercept is. And anyway, it'll make more sense once we get going. In fact, let's go ahead and get going. So first thing that we need to do is we need to graph this information. Now they're telling me that on the x-axis, it's actually not going to be an x-axis in this problem. It's actually going to be volts, okay, or voltage, scroll on just a little bit, measured in volts. So there we go. There's my first axis. And again, how do I know that goes on the x? Because it says it up here at this table. It says, look, your x-axis is going to be voltage measured in volts. So that's how I know. Next thing, I need to plot the y-axis. And my y-axis is I measured in A, which at this point in the semester, you guys should know that means current measured in amps. All right. Now, when it comes to scaling your axes, see, like, x is 0 all the way to 3.5. Okay, my x-axis is going to go from 0 volts all the way to 3.5 volts. So it would not make sense for me to go 0 to 10. That wouldn't make sense, because then what we would have is all of my data would be over here on this side, and that's not really what I want. So be intelligent about how you do this, okay? Really think about what your axis should be. I'm going to move that X label just a little bit because it's kind of in my way. Move it over there. There we go. Beautiful. Okay, so I am going to start with 0, but then I think if I go by 0.5, it's going to work out really nicely. In fact, let me check my key. I've done this before. Let's see here. Here we go. Yeah, I want to go by 0.5, so that makes the most sense here. Sorry about that. So I'm going to go 0. And guys, be really careful. Make sure that when you're writing this, you're being really neat. If you need to print it out, okay? Here we go, 0.5. And then we're going to go to 0 point, or not 0, be a 1, 1.0, 1.5. And notice when I'm doing this, I'm lining up with the line. A lot of students, when they do this, they put it like in the block, and that's not it. Line it up with the line. So 1.5, 2, 2.5, 3, 3.5, 4, 4.5, and 5.0. Now, obviously, we're not going to go all the way to 5.0. We actually know we're going to stop over here at 3.5, but that's okay. We still want to finish the axis. Now, my y-axis, okay, or in this case, current, measured in amps. Now, how do I determine this? Well, I can see that my values are going to range from 2.5 all the way to 2. 2.5 to 2. And sometimes it helps for you guys to kind of like estimate it in your head and say, well, what would happen if I went by 0.5s? And just kind of do it in your head. And as you go through, say, all right, I'm going to start with 0, 0.5, 1, 1.5, 2. And if we stopped right here and that would be 2.0, that wouldn't be a very good graph because once again, you're wasting all this space up here on the top. So maybe instead of going by that, maybe you should go by smaller increments. What if you went by 0.1? Okay, so I'd have 0, and again, I'm just kind of doing this in my head. 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. See, that's not going to work either. If I were doing it that way, I'd never make it to the 2.0 that I'm looking for. So just kind of guess and check these a little bit. I'm actually going to go by 0.25s because that actually makes the prettiest looking graph. So I'm going to go 0. I always start with 0, 0. It's a good way to do a graph. And I'm going to do 0.25, 0.50, 0.75. You guys know how numbers work. But that is how I'm doing this. I'm going by 0.5 every time. And again, I'm lining up with the lines. See, look at this. I'll make it really obnoxious for you. I'm writing it next to the lines because that's going to make our life a lot easier. Next, I'll have 1.75, 2.0. And if I wanted to, I could do 2.25. I can squeeze that in there. 2.25. There we go. Alrighty. Now, we are in business. Because the next step, and this is what you guys have been doing honestly since middle school, is you're just using the x and y components, or coordinates rather, and you're putting them where they need to be on the graph. So that's what I'm going to do. My first one is at 0 and 0.25. So I'm going to make it really big and obnoxious for you guys. See it down here? 0 and 0.25. And notice, because I wrote with the grid lines and not the boxes, I can put it on those intersection points, which is really great. 0.5 and 0.5. Wow, that's easy. Next one I have 1 and 0.75. 1.5 and 1.0. 2.0 and 1.5. Wait. 2.0 and 1.25, excuse me. And maybe it would help you guys to cross these out as you go along. I think I have done that before, but I'm trying to keep it neat. Next one is at 2.5 and 1.5, so that'll go here. Just making my dots kind of big. And the next thing is 3.0 and 1.75. And the last one is 3.5 and 2.0. Now that is a handsome looking line. If you guys are doing this on the computer, and again, I think it can be done on the computer, you just have got to make your axes look really neat. That's when a stylus is helpful, or, zoom in, use your finger. But one thing I'm about to do is I'm going to draw a line for this in a minute, because the thing is, guys, doesn't that look pretty linear? See, the thing is, if we had a graph that looked, I'm going to exaggerate, if we had a graph that looked like that, that wouldn't be linear, and we'd be having to make a second graph because we'd say, yeah, that's top opening. We're going to have to do a little bit of work with that. But it's not. This is a very linear graph. So I'm going to go ahead and draw my line, and I'm using the ink to shape option. I'm going to draw my line right through these. Carry it on off. Usually it takes a second for it to straighten up. If it does it. Well, there we go. Okay, so there we go. We got our nice, perfect straight line. It cuts through every single point, which is really important, and that works. Okay, if we were doing this on paper, you'd probably need to use a ruler right there. So the thing is, this other graph over here, this is not needed because it's already linear. The one over there is already linear, so we're good. All right, next thing, okay, we've got to find some information. Okay, we've got to find the slope, the intercept, and the equation. Let's start by doing the slope. And I'm actually going to write out this equation, rise over run. That's what I've been doing since middle school, and I still use it today. So we have rise over run. And what is my rise? Well, the thing is, we want to just pick a couple of points. It can be any 2 points on the graph, but they have to be on that line. Your linear line, you draw so that it cuts through as many points as possible, but next you really want to pick a couple points. So I'm gonna just pick a couple just to keep it simple. I don't know. How about this one? That one and that one. There we go. That works. So I've got me 2 points to work with. And so what is my rise? Well, let's see. My rise from here to here, I need to use a color that's a little bit brighter probably. My rise from here to here is going to be 1. because I start with 0.5, I go all the way to 1.5. Now, don't be one of those people that goes, all right, 1, 2, 3, 4. My rise is 4. No, that is not what that is scaled in. It's not scaled in whole numbers, okay? It's scaled in 0.25. So the whole is 1, okay? So be careful with that. So I have a rise of rise of 1. Okay, I'm going to go ahead and put that up here. And 1 what? 1.0 amps. Okay, because that's what the axis is measured in. Now, what's my run? So if I'm looking at a run, I'm going from here to here. So I go from 0.5 to 2.5. So my run is 2. And again, do not think, oh, this is 1, 2, 3, 4. No, that's not what it says. You start with 0.5, you end it with 2.5. That's a change of 2. Well, 2 what? 2 volts. So I'll come up here, and my run is going to be 2.0 volts. Okay. So we end up getting 0.5, and it needs to have some units. Okay, if there's one thing I've taught you guys, I hope that you should always have units next to your value. And in this case, it's amps per volts, which is kind of weird. That's kind of funky. I probably should have switched the axes when I was making this sheet, because then volts over amps would be ohms. Not like you need to know. All right, so intercept. Do we have one? Let's see. Let's see if we have an intercept. Yeah, our intercept is 0.25 amps because that's where it intercepts the y-axis. So I'll have 0.25 amps as my intercept. And again, every number I'm writing, I'm trying to put a unit next to it. And so now I have to make my equation. Now, guys, it's going to take you some time to get used to this, on doing these very specific equations that I'm giving you. But one thing that may help you is write it out. We know it's going to follow the y equals mx plus b formula. So write that down below and then say, okay, well, I'm not dealing with y in this problem. What am I dealing with? I'm dealing with current, capital I, measured in amps. So that's my y-axis in this case. My m, I just solved for it. It was 0.5 amps per volt. And my x, it's not an x this time. Okay, let's look over here. What does it say? It says we have volts measured in volts. Write that right there. My parentheses make it so it's m times x. You know what I mean? And then did I have an intercept? Yes, it was 0.25. So there you go. That's what we're looking for right there. All right, so there's our equation. And one thing I forgot is I forgot to do a title. Every graph should have a title, so I'm just going to go down here and say this is current. It's current versus voltage. There we go. We got a title now. So guys, that is what I'm going to be looking for. So just so you guys know how I'm going to be grading these, for this problem right here, I can see this many points. 1 point for doing the correct axis label on the y-axis, another point for doing the label on the x-axis, a point for scaling each of the axes correctly, a point for drawing all my dots correctly, a point for drawing my line correctly, that's a straight line that cuts through them, a point for the title, a point for the slope, the intercept, and the equation. So I'm looking at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points for this one problem based on you doing things that I'm asking you to do. Let me make these things go away because that's kind of obnoxious. All right, let's look at the next problem. This one's kind of weird. The rest of them, there's one trick, but the rest of them we will have to make a second graph. So let's see. Do I want to do number 2? Hold on. Let me see. Do I want to do number 2? Tell you what, I'm going to skip number 2, and I'm actually going to go on to number 3. Because I can. So let's look at number 3. Here we go. Once again, you're being told what your axes are. Okay, you're being told what your axes are. So my x-axis is actually not going to be an x. It's actually going to be velocity measured in meters per second. Not sure why I made that my v-axis or my x-axis, but whatever. So v measured in meters per second. Notice every time I do this, let me use square brackets, I'm writing my units with it. Okay, it's velocity measured in meters per second. And then my y-axis is going to be acceleration measured in meters per second squared, or m over s squared. So there we go. Title, let's just make it acceleration versus velocity. because that's what it is. Y versus the x. Excuse me for a moment. Okay. The next thing we need to do is we need to start scaling this axis, okay? We need to scale the axis. Let's look at the x-axis first. That one's actually pretty easy. Let's just go by ones. That's going to work the best. So again, see, it goes 0 to 7. So that's our range that we're looking for. So when I scale this, that's what I'm going to do. Start with 0, 0.0, 1.0, 2.0, 3.0. And again, I'm trying to line up with the lines, not the blocks. I'm trying to line up with the lines, because that's what's actually important. There we go. And I know we're not going all the way to 10.0. We're going to have a little bit of wasted space over here on the end, but that's about as good as we can do without getting really weird with our decimals. Now what about my y-axis? Acceleration goes from 0 all the way to 2.08. 2.08, which is fun. I actually don't like how I did this one. I added an additional line, and I don't really like that. Let's go by, what did we end with in that last one? Let's go by 0.25s again. I think I'll be happy with that. Let's go by 0.25s again. I think that'll work. So I'm going to go 0, because that's a good place to start. 0.25. 0.50, 0.75. And by the way, guys, when I'm doing this, I am zoomed in super far because I want to be really neat. I want to make sure that my numbers are lining up with the lines. There we go. That'll work. All right, that'll work. Okay, so we're having a little bit of wasted space, but that's better than adding a additional area to the graph, and I don't like doing that. All right, let's start plotting some stuff. So as I look at this, my first one I see is 0.0 and 0.0. Hey, that's nice. That's an easy one. So I'll just put a dot at the origin, okay? And I know I'm writing down here, but I want you guys to be able to see what I'm referencing on the graph. So there's my first one. I got the origin. The next one is 1 and 0.7. So 1 and 0.7 is going to be maybe right there. Okay, and I'm just getting as close as I can with my dots. My next one, so that one's done. I'll put a little check mark. Next one is 2 and 1.1. So 2, there's 1. So let's say 1.1 is like right there somewhere. All right, so 2 and 1.1, check. 3 and 1.39. So that's going to be, kind of right there in that area. Okay, so I'll check that one off. 4 and 1.61. So that's going to be maybe here. And again, I'm doing the best I can with estimation. It would have been easier if I could plot this graph all the way to the 10th place, 0.1s, but I didn't really have that option. Next is 5 and 1.79. It's going to be right there. Next one is going to be, stop moving, 6 and 1.95. So that's going to be 6. 1.95 is going to be right there. And then the last one is 7 and 2.08. So let's say that goes maybe right in here somewhere. So guys, if you're looking at this, it is going to be really tempting for you to say, oh, well, I can draw a straight line through that. No, you cannot. Okay? The only time you should be drawing a straight line is when you're drawing a linear straight line. Okay? Because the thing is, some of you are going to be like, oh, I just want to connect the dots and make it all curvy like this. No, don't do that. In fact, I encourage you not to do that. If you're putting a line on a graph, usually it needs to have an equation associated with it. And in this case, there shouldn't be an equation. So let me take that line away. That is enough, though, for you guys to see this is a side opening graph. In fact, I'm going to write it down below. You don't have to do this, but I think this is helpful. So this is a side opening graph. That means that it looks vaguely like that. Okay, let's go look at our notes. Okay, let's go look at our notes and see what we need to do then. So I'm going to go back, all the way back. That's chemistry. Let's go all the way back to our folder, physics graphing notes. Here we go. There we go, side opening. And what does it say we need to do? We need to square the y-axis. We're going to square the y-axis, not a problem. So what that means then is I'm going to make a new column. Okay, I'm going to make a new column. excuse me, on my graph. And this is going to be called the y squared column. Okay, that's what we're doing. In fact, I'll write it down here. Well, how are we going to fix this? We're going to do y squared. And by doing that, okay, that's going to hopefully straighten out our graph a little bit. So I'll go up here. I've got my y squared column. It's not going to be called y squared. It's going to be called a squared. Okay, look, we are squaring this column. Everything's being squared. So we have a squared, and what are my units going to be? Well, they're going to be kind of ridiculous made-up units, but it's going to be m squared over s to the fourth is technically what the units would be, which are kind of stupid. But anyway, that'll work. So this is what I'm going to do then. In my calculator, for every single one of these, sorry for my arrows, I'm going to square them. That's what I'm going to do. This is creating a calculated column. So 0 squared is 0. I did not type that in my calculator. I just want you guys to know that. I stopped myself. This is going to be 0. Next one, I'm going to do 0.7 squared. I get 0.49. Next one I'm going to do is 1.10 squared, and I get 1.21. And I'm not going to bore you guys with the rest of this. I'm going to go ahead and fill out the rest of it and hope that my past self that did this a few years ago did his math right. And I think so, because this next graph looks really pretty, so it's going to work out. And so again, that's all I did, is I just squared all my values, okay? So let's make a new graph, all right? Now that we have this information, this is what I'm going to be plotting on the new graph. X is staying the same, and by staying the same, I mean that it's not X, it's going to be still velocity measured in meters per second. That's still what I'm going to have over here. But now instead of A, now it's going to be a squared, okay, right? It's going to be a squared measured in these weird meter squared per s to the fourth type deal, okay? So I'm doing that and that, okay? Now when it comes to scaling, my x-axis is still going to be scaled exactly the same way. So I'm going to write that real quick, but I'm trying to keep it neat, as you guys should. Don't rush this. I'm going to give you what I consider to be plenty of time to do this assignment, so don't rush this. Take your time, do a good job. Make sure you're not missing anything. And now we got to scale this new axis. So I can't scale it the same way as before. The old y-axis ended with 2.08. This one ends with 4.33. And so it looks like my past self decided it was best to go by 0.5s. So that's what I'm going to do. I'm going to go 0 and go to 0.5. 1, 1.5, 2, and so on. And a good way to check, guys, is look back at that axis, my a squared axis right here. I start with 0, I go to 4.33, all of which will fit on the axis that I just made. So that's really important. Let's give this thing a new title. It's not acceleration anymore, it's acceleration squared versus velocity. Okay, so there we go, we got a title that'll load up there in a minute. Hopefully now. And go. There it goes. All right, so we have acceleration squared versus velocity. That works for me. All right, so now that we've done that, it's just going to be plotting on the graph. So I'm going to use my table up there. Okay, and I'm gonna plot it. So at this point, just so you guys are clear, we are plotting x and y squared. We are plotting those two. We are not messing with the middle column anymore. Don't let that mess up your brain. Just slow down and say, all right, 0 and 0. That's going to be my first one. 1 and 0.49. That's going to be my second one. So just be careful with that, okay? So the first one's going to be 0, 0. That's pretty nice. That's going to be pretty nice. Let's keep using red. There we go, 0 and 0. I'm going to check that one off. Next one's going to be 1 and 0.49. So I'm going to put it right there. The next one is going to be 2 and 1.2. So that one's kind of going to go, it's not perfect, but it's better. It's a little straighter than it was, so it'll go like right there. The next one is going to be 3 and 1.93. So that one's going to go vaguely there. Sorry, I said I was going to check these off as I was going. There we go. Next is going to be 4 and 2.59. So somewhere in that area. The next one is going to be 5 and 3.2. So that's going to be kind of right there. I know this is exciting watching a person graph, but it's good for you. And hopefully you're doing this with me or checking your work. 6 and 3.8 is the next one. It's going to be kind of in this area right here. And you guys should see this is much better than our last graph. This is much more linear. There we go. There's my last one. Okay, check. We've done them all. Again, I'm going to use my ink to shape tool. I'm going to draw a line on here because now that it's linear, I can draw a line through it. And there we go. So hey, that's not too bad. And again, when I draw my line, I'm trying to get as many of the dots as I can. It's not perfect. It's a lot better when I actually have a ruler, personally, but it's not really an option. So that's about as good as I can do. I'm very happy with that. Okay, I'm very happy with that. So next thing, we need to find out what the slope is. Okay, I need to find out what the slope is. Now I'm still going to use rise over run. Go ahead and write it down, not like it matters. So I'm still going to do rise over run. But what's really important here is finding a couple of points where it matches, like where it goes across a grid line, basically. That's what's really helpful. So as I'm looking at this, I think I'm going to pick these points right here. This one crosses the grid lines really nicely. And honestly, I could go on up the line. I think I'm just going to use 0, 0. That'll be easier. So I'm using these X's to show you that's where it crosses a grid line. That's a really good place to do your rise over run based on those 2 points. Because remember, guys, you're going to be tempted to do rise over run based on your points, you know, my red dots. That is not what your equation is based on there. The line is your equation. So I'm looking at the line. All right, rise. It is going to be, and again, don't do that thing a lot of students do where they say, well, that's 5 blocks, so my rise is 5. No, it's not. You are not in middle school. So the rise is 2.5. Okay, I'm going to go up here and add it. The rise is 2.5. And it's these weird units of meters squared over seconds to the 4th. I know it's dumb. I don't know what I was thinking, but anyway. And my run, let's look at my run, goes from 0 to 4.0. So it goes 0 to 4.0 is my run, so 4.0. 4.0 meters per second is what it's going to be. So I'll go up here and write 4.0 meters per second. And luckily these units are going to straighten themselves out just a little bit at least. I end up getting 2.5 divided by 4, 0.625, which is I think 5/8. Not like we care. I like decimals. You guys should like decimals, so use decimals. 0.625. And my units, I'm not going to get into the algebra. Just trust me. It's meters per seconds to the 3rd, which is a made-up stupid unit. Please load OneNote. I don't have time for this, and neither do they. Can you please load a little bit faster? Thank you. So there we go. Notice I'm putting my units. Intercept. Did we have one? Not really. It intercepted at 0, 0. So I'll still write it as 0, 0, but that's my intercept. 0.0, and the units are meters squared per seconds to the 4th. There we go. Now my equation. Once again, I recommend that until you guys get really good at this, and you can do it in your head, just write out y equals mx plus b down there, and kind of think of it as a fill-in-the-blank type situation. So it's not y. What was it for this graph? A squared. Okay, so I'm going to write a squared. And what were my units? These weird meters squared per seconds to the 4th. There we go. Now it's not m, okay? I just found the slope is 0.625 meters per second to the 3rd. It's not going to be x this time. It's going to be, let's go look, velocity measured in meters per second, okay? So we have v measured in m over s. And technically, you could stop right there. We don't really have a b for this equation, but I'm going to be fancy, and I'm going to add it on because it's good practice. So 0.0 meters squared per seconds to the 4th. There we go. There we go. And so, in this problem, that's what I'm looking for. And guys, there is a lot of stuff that I'm looking for, whether it's your axis labels, your axis units, how you scaled your axis, Is your equation correct? There's a lot of stuff that I'll be looking for there. Okay, I think I've got time to do one more. This is already going to be kind of a long video, but what I anticipate is as you guys start this, you guys are going to be wanting some help. Let's go take a look at... Let's go take a look at number 6. Yeah, I want to do number 6 because it's a fun one. Okay, we'll do one more. Let's go look at number 6. All right, so here we go. Once again, first things first, I need to go ahead and start setting up my graph with the axis labels. In this case, I'm not doing X and Y. I'm never doing X and Y, but I am doing radius measured in meters versus force measured in newtons. That's what that stuff stands for, and hopefully we'll get a chance to learn about that this year. So we've got, let's just call it force versus radius. That's a good title. X-axis is first, and hopefully you guys, that one's kind of easy. You should know how to scale that. Let's just go by tens, right? So my x-axis, which again in this case is r, I'm just going to go by tens. All right, so that's what I'm going to do real quick. I'll start with 0, 0, 10, 20, 30. Lining up with the lines, not the boxes. There we go. So that's what I'm looking for. Now what about my other axis? My other axis is force measured in newtons, so I'll go ahead and write that up here. Force measured in newtons. And boy, that's some confusing numbers. Let's see, what did my past self decide to do? What? I mean... Okay, well... My past self decided to go by 0.04s. So it went 0, 0.04, 0.08, 0.12. I'm going to go by 0.05 instead. I think that'll work better for us. So I'm going to go by 0.05s instead. That'll work. So here we go. I got to focus on this. So if I'm not, see, that's what happens when I started talking. There we go. And that's going to work out really nice. My largest value is 0.37. That's definitely going to be here. My lowest value is 0.03. That one's obviously going to fit on here as well. So always look for your high-low. Make sure it's going to work on your graph. So let's go ahead and start doing some graphing. My first point is 10 and 0.37. Okay, so it's going to be roughly in here somewhere. Okay, so I'll check that one. Check that one off. Next one is 20 and 0.22. So let's say that's going to be right in here somewhere. Check that one. Next one is going to be 30 and 0.14. Yeah, this is definitely much easier than going by 0.04s. That y-axis is much easier to read in fives. 40 and 0.11, so that one's going to be like right there. The next one I have is 50 and 0.07. Look right there somewhere. Next one is 60 and 0.07. Oh my goodness, we can't do that. Mr. Narron, you must have made a mistake. Guys, understand I made these purposefully kind of annoying with some of my numbers because I didn't want it to be perfect. If you're dealing with lab data when you get to college, they're not going to be perfect. It's not going to be a perfect inverse function, okay? Data rarely is perfect. So there we go. Something like that, okay? So by looking at this graph right here, and again, fight the urge, fight the temptation to say, oh my gosh, I gotta draw a line, there we go. No, you don't draw a line right there. If you're drawing a line, you better have an equation that goes with it, and I have not told you to do any inverse equations, so don't do that. Now, this does help us in the fact that we know we're dealing with a, did I call it inverse? I think I may have just called it inverse in the notes. But that's the type of graph that we're dealing with. That is kind of helpful, but that line is not helpful. So I'm going to go ahead and take that off of there. So let me go look at my notes real quick and see what we need to do then. And that's what you guys should be doing. Come on, mouse, wake up. So I'm going to go back over. And hey, what do you know? It's an inverse. An inverse, it says I need to do 1 over the x-axis. I got to do 1 over the x-axis, and that's going to straighten things out. So let's go see if we can do that. 1 over the x-axis. So let me write that down. Oops, let me use a pen. There we go. So I'm going to do 1 over x, and that's going to fix it. So let's see that. Let's see what happens when we do that. So my new axis is going to be the 1 over x-axis. And so what does that mean I'm dealing with? Well, I had radius in meters before. Now I'm doing 1 over the radius measured in 1 over meters. Okay, just like that. Yeah, that works. I was just checking my old work over there. So now that I've done that, what that means is every time I'm doing a calculation, I'm dealing with the x-axis. And every time I'm going to do 1 over x. So my first one, literally what I'm typing in the calculator is I'm typing in 1 over 10. That gives me 0.10 or 0.1. My next one's going to be 1 over 20. That's going to be 0. No, that's not right. 1 over 20, 0.05. And so on. Okay, so that's what I'm doing here. I'm going to go ahead and quickly fill out the rest, and you guys can pause the video and try and do this on your own. Maybe check your work. But otherwise, I'm going to go ahead and fill it out. There we go. Alrighty, so there we go. I'm going to go ahead and erase this other junk because I want to keep my work kind of neat. But that's what we're looking for here. All right, let me scoot these over and center them. I know that doesn't really matter, but it matters to me. Can I really not? Oh, my goodness. No, stop. No. Oh, my goodness. I have stuff to do. I don't have time. Ugh. That was, okay, that was a little OCD. That was not necessary. All right, so now that we have this information, we can go ahead and start making our new graph. It's worth mentioning, force stayed the same, so that whole other axis over there is still going to be the same. In fact, can I cheat this? Because that would be really helpful. Hold on. Copy. And I want to paste. Paste. All right, great. So it sort of worked. I think I messed up a little bit. In fact, by the time I'm done doing this, I probably could have had it done by now. There we go. Beautiful. There you go. Boom, got a whole nother axis. All right, but my x-axis has now changed. So it's 1 over r now, which is measured in 1 over meters. And again, this just kind of takes practice, guys. It looks like I'm going to go by 0.01 this time. That works the best. That way, I have all the way from 0.013, which is my minimum. Okay, always identify your min and your max. Here's my minimum. It's going to be 0.013. My max is going to be 0.10. So by going by 0.01s, that's going to make us a really nice axis down here. So let me do that real quick. Is that what I did? Yes. Sorry, I'm not talking much. I'm focused. But you guys can do that on your own, probably. Okay, guys. Title. We do need to have a title. It's going to be, I guess, force versus, I don't know, inverse of radius. Or inverse radius. That works. Just need to have a title. Every graph should have a title. It should be the first thing that you see is the title. Okay, next thing. Let's start plotting some points. And same as before, be careful, okay? I am only plotting the y and the 1 over x. I am not messing with this side over here anymore. So just know that's what I'm referencing. So my first one is going to be 0.1 right? 0.1 and 0.37. So that's going to go like right here and right in here. There we go. That doesn't look right. Oh, 0.1, not 0.01. Duh. Sorry, guys. It's okay. This one's going to plot in reverse. That's all right. So here's 0.1. Here's 0.37. Y'all see that dot? It's right over here. It's loading. 0.1, yeah, 0.1 and 0.37. So we're actually going to be plotting this one in reverse, which is okay. That works. So done with that one. Next one, 0.05. Woo! Cut all the way back here. And 0.22. So that's going to be, it's going to be kind of in this area right here. Okay. My next one is going to be 0.033 and 0.14. So 0.03 is like right in here, and 0.14 is right in there, so like right here. Yeah, this is a hard one to graph. That's why I picked this one. That's why I picked it. The next one is 0.025 and 0.11. So 0.025 is going to be kind of in here. 0.11 is going to be just above that line, so it'll be like right there. And I know this is kind of small, guys. I'm doing the best I can because I want you to see everything that I'm doing. Next one is 0.02 and 0.07. So here's 0.02. 0.07 is like in this area. The next one is going to be 0.017 and 0.07. Kind of in here somewhere. It's going to make my graph kind of ugly, but it'll work. It still works. The next one is going to be 0.014 and 0.05. It's kind of in here. Okay, see how my dots are getting kind of clustered up down there in the bottom, but that's kind of the nature of this type of graph. When you do an inverse and you do 1 over the x, it kind of makes this happen. Next one is 0.013 and 0.03. So finally, we're about done with this. Let's put it right there. That looks fine. Okay, guys, so this is what we've got. And close enough, it's going to cut pretty close to 0, 0, and I think to make my life well, it's going to be a little less than that. It's all right. Here, I'll draw a line and I'll show you what I mean. So at this point, we can see this actually did straighten things out. It's not beautiful, but it's gonna work. Okay, go away. There we go. That'll work. Again, I'm just trying to get as many of the dots as I can. I probably could have turned it just a little bit more, but that's not bad. And what I wanted you guys to see is there is sort of an intercept here. We're going to kind of have to estimate and say, well, this is, I don't know, this is down here somewhere. That could be negative 0.02 newtons maybe. But yeah, it does kind of have a little intercept on it. Anyway, let's do one thing at a time. Next thing is going to be the slope. Slope is always rise over run. So I'm going to do rise, I'm going to do over run. My rise, all right, I got to find, again, I'm looking at the blue line. It'll load in a second. I'm looking at the blue line. I'm not thinking about the dots, and I'm trying to find where it crosses a grid line. So that means like right here, that's a really good spot. OneNote, if you could load, that would be really helpful. There it is. And I think this one right here is another good one to choose. There's another spot where it crosses the grid lines. Come on, OneNote. Come on. Do it. You guys can probably see it even before the X loads. There we go. So the reason I'm picking those two is, once again, they cross the grid lines. It's going to make us a really pretty graph. And let's look at my rise over run. So my rise goes from, and I'm actually going to write it out this time. Maybe that'll make a little more sense to you guys. It goes 0.35 newtons, and it went from 0.15 newtons. So that means my rise is 0.20 newtons. Okay, so I'm going to go write that in. 0.20 newtons. And my run, let's take a look at this run, goes all the way up to 0. Can I do better than that? Let's make that look a little bit prettier. Here we go. 0.090, right? And this is going to be inverse meters, which is a stupid unit. and it came from 0.040 inverse meters. See that? It went from here to here, basically. And the other one, just so you understand what I'm referencing, went from here to here. Okay. So I end up getting 0.050 inverse meters. So there's my run. Let's go up here and see what I got. Okay, so that's where I'm at. I'm going to do some math in the calculator real quick. I have 0.2 divided by 0.05, and I get 4, which is a nice round number. For what, though? Watermelons? No, just trust me, this ends up being 4 Newton meters, and if you want to look at the algebra, you can do that on your own time, but it's newtons times meters are what the units are going to end up being. Intercept, I already kind of told you, we had to cheat a little bit and kind of imagine that that does kind of keep going below, and I just made it negative 0.02, and that does have units. Okay, the y-axis is measured in newtons, so let's give this some newtons. And so my equation, once again, I think it's best to write that out just so you have a reference. Y-axis is not a y-axis in this case. It was a force measured in newtons axis, so I'll go ahead and write that in. So F measured in N is equal to, my slope was 4.0 Newton meters. Put that in parentheses so I can multiply it by my x. My x in this case is going to be 1 over r. Okay, and that's going to be measured in inverse meters. And I did have a slope. I decided my slope was negative 0.02 newtons. And you can write it this way. I actually like that way a little bit better. Or if you want to be all fancy, I guess you could technically do minus 0.02 newtons. And that works just the same. Okay, so there you go, guys. I hope this was helpful. I know this was a long video, but I anticipate you guys are going to have some questions about it. I will go ahead and give you another hint before I let you go about problem number 5. So just know problem number 5 is a little weird. You may not need a second graph. It may be linear. Just be really careful when you scale your axis on number 5. I'll go ahead and give you a hint. I scaled my axis on number 5. In fact, I'll go ahead and go over there and show you what I mean. Okay, my axis on number 5, I went from 0 to 30. 0 to 30, and I went by 3s. That is going to be really important. One thing I don't recommend, and a lot of students are going to try and do it, is they have had classes before where you basically don't start at 0, because you look at these numbers. A lot of people are going to look at that and say, well, the numbers kind of bounce around in the low 20s, so why wouldn't I just go from 20 to 25? Don't do that. The pattern will make a lot more sense if you spread it out. So I always recommend don't always start from 0. Okay, when you're scaling an axis, always start from 0. And by the way, that's going to be in delta x measured in meters. Good luck, guys. I hope you have a good one.